Recently, I've begun building a glass blowing section here at the art studio. This here is the current state of the glass blowing section of our studio, but I'm missing a very important piece of equipment known as a reheating chamber, or more commonly known as a glory hole. Luckily, I got in contact with somebody who's selling the exact piece of equipment that I need. The only issue is that it's in very rough condition. So in today's video, we're gonna buy the equipment and go through the whole restoration process. And hopefully by the end, we'll be one step closer to completing the glass blowing studio. This here is the glory hole that we're going to be buying. As you can see, it's in really rough shape. It's been sitting under this tree for probably years at this point. It's also extremely heavy, so we had to use this tractor to load it in the back of the truck. Once it was secured, we brought it back to the studio, and now we can begin the restoration. It's in pretty rough shape. A lot of the doors are starting to crack. You can see the inside needs a lot of work done as well. The kiln brick is starting to fall apart. There's a lot of dirt, a lot of spiders, a lot of stuff that we gotta fix. Fortunately though, when I bought it, it actually came with a manual on how it was built and all the components that were used. And the first thing we're gonna do is remove the doors, and then we're gonna clean out the inside and assess the damage to see what needs to be repaired. After removing the 4 bolts on the door frame, I pulled it off and the entire front of the insulation completely collapsed. With the doors and the frame off, we're going to sweep out the inside, removing any of those small bricks as well as all the different debris. All the debris on the inside is gone, it's nice and clean. The entire bottom here is supposed to be lined with these bricks. I don't know what happened to them. When I bought this, they were all missing on the very bottom, so we're gonna have to replace them. I'm gonna go ahead and order the bricks off camera, but in the meantime, we're gonna go ahead and fix up those doors. Now the refractory on the door is actually in pretty good shape. So all I'm really gonna do is remove all the rust on the metal and then repaint it with some high temperature paint. There's a couple areas that may need a little bit of repair. If I find any spots on the metal that have a lot of damage, then I'll go ahead and repair that, but I don't think there's anything that's too badly damaged. The rust on the doors wasn't really that bad, so I used this small wire wheel to remove pretty much all the rust. The tab here that's used to hold this in place is a little bit worn down, so I'm going to weld a new one on right here. I'm also going to add one right here as well. With the repairs done, it's time to add a fresh coating of paint. After painting all the doors, I realized that this large one here has this metal rod at the very top, and the other large door is currently missing it. The whole purpose of having these rods on the door is that it gives you something to hook onto so you can open and close the door. Because when you have this thing running, those doors get really hot, so you can't actually open it by hand, so you need something to hook onto to open the door. So I'm going to regrind off this paint, make it nice and smooth, then I'm going to attach a rod like the one on that door there. All the main metalworking for the doors are pretty much done. We still have to patch up a little bit of the refractory, but we'll do that later. So I just went ahead and ordered all the new refractory, all the breaks and insulation that's required to fix the inside of this. But in the meantime, we're going to work on the gas system. I thought removing the gas was going to be a lot harder, but luckily the people that built this before me put a lot of what are called unions on it, which are kind of connection points, so it made it very easy to pull apart. You can see there's a lot of surface rust on the stand. There's also a lot on the actual can of the glory hole. And we also have to clean this up a little bit as well, but I don't think I'm going to remove this. Regardless, we're going to start by cleaning up the can and the stand of the glory hole and then getting everything repainted. Instead of a drill with that small little wire wheel, I broke out the big angle grinder and this super beefy wire wheel because we have so much more surface area to cover, and I really wanted to try to make quick work of this. Okay, I've removed most of the rust off the stand. Now we're going to paint it with this high temp paint. Now we're going to focus on grinding the sides of the can and getting that painted as well. Just like before, we're going to be using the big angle grinder to remove all this rust, but there was so much surface area that I had to cover, it made it pretty hard to remove everything. And as usual, once we're done, we're going to apply a coating of paint. Alrighty, all the rust has been removed and everything has been repainted. The stuff that I ordered hasn't come in yet, so we can't work on the inside. So instead, we're gonna start figuring out and working on the gas system. This is the current remains of the gas system. The way they had this was really complicated and it had a lot of nice components on it. So what I'm gonna do is remove most of the pipe and get all those components off, and then we'll figure out what we wanna use. These here are the components that I managed to get off of the old system. The ball valves all look good, so we'll probably reuse these. A lot of the fittings here are pretty rusted, and the inside on them don't look that great either. And since we're not going to be using that many fittings in the new system, I'm just going to toss these ones out and we'll buy some new ones. As for all the 2-inch gas pipe that was attached to the burners, we're not going to use any of it. Not only is it really rusted on the outside, but on the inside it's also like really nasty, so we're not going to use any of this. Now that we have everything taken apart, I was going to go ahead and rebuild the gas system, but all the insulation that I ordered online came in today, so we're gonna work on that instead. Initially, I was just going to place bricks here on the bottom and then try mortaring some on the very top. Most of the bricks are starting to pull away from the second layer of insulation, so I think we just have to redo everything. We'll start by removing all the bricks from the inside, being as careful as possible because I do want to reuse these. Okay, maybe I could have gone a little bit slower. Nonetheless, we got them all out with very minimal damage, so we can reuse most of them. Now we're going to take the cylinder off the stand and place it on the ground. The cylinder is really heavy even without the bricks inside, and luckily it's not welded to the stand, so I can lift it up and put these straps on it. Once all the straps are on, we're going to use this forklift to lift it up and place it on the ground. The first thing I want to do is patch up the back side of the insulation. I'm going to patch it using this high temperature mortar. I was debating whether or not I wanted to just patch it or replace all the back insulation. After inspecting the back, I decided to just patch it because there really wasn't that much damage. There's a pretty big gap inside this hole here. I'm going to mix up some castable insulation and pour it into the hole, and then we'll finish by patching it up. Next up, we're going to put these bricks back into the hole. You can see there's a lot of dried mortar left on the sides of the bricks. To deal with that, I'm going to take a chisel and scrape off all the mortar on the bricks, but this also isn't going to be enough bricks to re-insulate the entire thing, which means we're also going to have to use all the other bricks that we ordered. The plan was just to use this scraper to scrape off all the mortar, but you're about to see why that wasn't a great idea. No! Alright, time for a new plan. All the bricks here are cut at a 10-degree angle, and we have to do that with all the other bricks in the boxes. So instead of using a scraper to get rid of all the mortar on the bricks, I'm just going to use the saw to kind of cut away the mortar on the sides. And at the same time, I'm also going to cut all the other bricks while we're doing these. Unfortunately, the saw that we have right here is too small to cut those bricks. So I went on Facebook Marketplace and I found this really nice saw that was available for purchase. I'm going to go ahead and set up the saw, and then we're going to get to cutting the bricks. Alrighty, I got all the bricks cut. They have that nice 10-degree angle to them. Now it's time to take all the bricks that we just cut and start stacking them into the hole. This is the first time I've ever done something like this, but it was honestly a lot of fun to do. There's something very meditative about mortaring and stacking bricks together. And just like that, all the bricks have been installed. I got 2 little ports cut out for the burners to fit in. The joints are obviously a bit messy. I'll try to clean these off camera, but if not, then just have to live with it. Now I made the bricks a little bit taller than how they were before, so I'm gonna have to add some more fiber insulation in this little gap here. Now that we have all the bricks installed into the hole, it's time to build the heat retention ring. The heat retention ring is essentially just a ring of insulation that's gonna go around the perimeter of the hole. It'll extend beyond the bricks about 1.5 inches. The reason you put one of these on is to help hold heat inside of the chamber. We're going to be making it out of this castable refractory here. It's essentially just a powder that you mix with water, and then you can pour it into a mold. I'm not even sure if we have enough of the refractory. I might have to buy more. The first thing I'm going to do is build a plywood template that matches the perimeter of the circle. Now that we have it traced, we're going to bring it to these sawhorses and cut it out with a jigsaw. The template is going to act as the bottom of the mold, and I have these like plastic strips that I just found lying around, so I screwed that to the side, and then I used some packing tape to seal up the corners. Now we're going to cut a circle out of some foam and put it in the very middle of this mold, turning it into a ring. I wanted the ring to overhang the bricks about 1.5 inches, so I made a paper template of the size of the center that I wanted. Then I used it to cut out 2 sheets of styrofoam that I stacked on top of each other and put in the center of that mold. It is now the moment of truth. We're gonna mix up all that refractory and we're gonna pour it into the mold. I want it to be about 2 inches thick, so hopefully we have enough. And if there's any leaks in this mold, hopefully we can fix it. Otherwise, we might have to try this over again. But there's only one way to find out, so let's get to it. When I was making this, I was going for a milkshake-like consistency, but in hindsight, I probably should have made it a little bit thicker. At this point, I was starting to get a little bit nervous because it did not look like I was going to have enough. I used the entire bag of refractory, and it seems like that was the exact amount, so we got lucky. A couple of days later, we're ready to take the ring out of the mold. While it was drying, there was a couple of small leaks, but I quickly fixed them. After removing the walls of the mold, we're going to take it to the table and remove the styrofoam. You can see the spots where the tape was and where it wasn't, and it's kind of interesting. It gives it a very glossy look. I don't know why. The tape left a bunch of wrinkles and holes in the casting, but I think we can fix that. Before we try to fix anything though, we're gonna take this ring and try and test fit it and see what parts need to be adjusted. The ring isn't perfectly round, so I had to try different angles to see what fit best. Then I marked all the protruding areas with a pencil and then sanded it down with a belt sander. After a few adjustments, we got the ring to fit. I went ahead and sanded the inside as well because I wanted to sort of round it out a little bit more. The final touch was to sand down the top of the bricks, that way it had something flat to sit on. Alright, the heat retention ring is now fitted in place. Everything looks good. It's got a bit of a small gap along the sides, but that's not going to be a big deal. We'll cover that later. The width of the hole is a little bigger than 15 inches. The top down is about 16.5, so it's not perfectly round. We still need to add some more insulation into this gap here, but we're going to do that later. Now it's time to fill in all of these air bubbles and gaps on the back. I'm using the same mortar that we used on the back of the hole, and I'm going to use a scraper to press that mortar into the little bubbles and creases. All the high temp mortar has been applied to all the holes, so now we're going to let this dry. In the meantime, we have to build a bracket system that's going to hold the ring in the hole. This one's going to be really basic. Eventually I want to build a nice one, but for now this will do. Alright, the brackets are all done, so now we're going to weld them on. This here is my first MIG weld, and not very pretty. This here's my last one. I got a lot more consistent with it near the end. Now we're gonna grind all the welds to try to hide the ugly. And as usual, we're gonna paint everything with some high temperature paint. Before we install the ring back in place, I'm gonna put some fiber in that gap between the bricks and the outside of the hole. Eventually, I want to get a piece of angle iron that goes around the entire outside, but for now this will do. At this point, we're done with all the insulation work, so now we can take the cylinder and put it back onto the stand. Moving it this time was much heavier because of all the stuff that we put inside of it. But with a little bit of help, we managed to get it mounted back onto the stand. Now we're going to work on the doors that will attach to the front of the chamber. This here is the current state of the front doors. Before we install any of them, we're going to go ahead and quickly repair any damage. Just like before, we're going to be using high temperature mortar, pressing it into all the gaps and cracks. Now it's time to test fit the doors to make sure everything works. The collars are installed, all the doors are in place. The only issue is that the gap between these two doors is really small, so it's causing it to scrape a little bit. To fix the problem, I'm going to cut off each of these angle irons on the top and bottom. Then I'm going to move them over just a little bit and re-weld them in place. Newer versions of this use different types of hinges that are adjustable. That way you don't have to cut it apart and re-weld it every time you want to change the spacing. And if I ever have to rebuild the doors, that's probably what I'll do. But for now, this fix will be fine. There we go, the gap is much bigger, so now we don't have to worry about the door hitting even when it's hot. Now we're gonna go work on the gas system. So I drew out how I wanna set up the new system. I'm still keeping a couple of the electronic safeties, but for the most part, it's going to be much simpler. The first section we're working on is this part right here. Just got back from the store, bought a bunch of fittings and a few pipes. This is definitely not everything I'm going to need, but it's enough to get started. The way it was designed before, these two burners were completely separate. This time we're going to connect both of them together, making it much simpler. the 2-inch gas pipe has been plumbed in. Okay, so now that we have the entire 2-inch pipe section complete, now we're gonna work on the gas supply line as well as the mixer that's going to mix the air with the propane. Just got back from the store. Time to assemble everything together. We're gonna start with the bottom half of the gas system. Just like with the burners, we're gonna try and simplify this system as much as possible and reuse any components that we can. We just finished the lower section, so now we're gonna work on the upper. This portion we're adding a solenoid valve, which is very important because it's essentially an electronic valve that shuts off when power gets cut off. This is very important because it prevents any sort of gas buildup or explosion if the machine loses power. Okay, almost all of the entire gas supply line is finished. This here is the section of pipe that we just completed, but we still have to make the mixer. We're gonna be making the mixer out of this 3/8 copper tube. We're just gonna cut a little section off, we don't need much. We'll then crimp it and fold it over itself with a hammer. Now we're going to take a drill with a really small drill bit and we're going to drill some holes into the side of the tube. This is what the gas is going to spray out of. Using a compression fitting, we're going to slide the mixer into the 2-inch gas pipe and then lock it in place. The mixer has been installed, so now we can attach the rest of the gas. Alrighty, the gas line is now installed. I added a couple of supports to hold the weight of the pipe. I added some plumbing strap here on the bottom to prevent it from twisting. This here is everything that we have built so far. Since we're done with all the gas pipe, we're now going to focus on installing the blowers. Originally, I was going to put 2 of them on, but I think that's too much, so we're just going to stick with 1 blower. What the blowers do is they take air and they push it through the system, which mixes with the gas. That gas-air mixture then gets pushed up through the burners, which then gets ignited, and that's how you heat up the entire chamber. The original setup had 2 blowers on it. I'm only going to use 1 because I think 2 would be too powerful. The blowers were sitting outside for a long time, so I want to make sure that the motors are actually even functional. I started by taking it apart and cleaning out the inside. I re-lubricated the motor bearings and everything, and once it was done, I assembled it and gave it a quick test. Now that we know it works, it's time to install it. First thing we have to do is find a place to mount it. So I got this steel plate right here. We're gonna weld it right there. This will give the fan a nice platform to sit on. Now we're gonna take the motor, place it on the plate, and attach it using a couple of bolts. All right, the blower has been mounted. Now we have to connect it to the 2-inch gas pipe. Since this part of the piping isn't going to get hot, we're going to make it out of PVC. Once we have all of our measurements, we're going to cut off all the excess pipe. We're going to glue it all together to make sure it stays together. Then we'll finish by attaching it with some rubber fittings. The blower's been mounted, everything is piped in. The ball valve right here is going to allow me to control the amount of air going into the system. And as an added bonus, when we turn the blower on, it's much quieter than it was before. You can see that there's air flowing through both of the burners. With the blower section now complete, all we have left to do is to add the safeties and wire everything together. For the electrical work, we have 3 things we gotta do. The first is to install this pressure switch. Secondly, we're gonna reinstall this flame sensor. Finally, we're gonna install this entire control box. Before I did anything, I wanted to come up with a quick plan. That way I knew what controls I wanted to use and how I wanted to wire them together. With our plan ready, it's now time to get started. Starting with the pressure switch, this is very important because if the airflow ever turns off, it'll cut off the gas. Next up is the flame sensor. This detects the flame inside of the chamber, and if for some reason it ever turned off, this would also shut down the gas. Now that we have our 2 main safeties installed, it's time to work on the control box. This was definitely the most complicated part of the entire project. I spent a lot of time cutting away some wiring that I knew I just wasn't going to need. And as for all the controls that we are going to use, I took those apart to inspect the wiring to make sure everything was still fine. Luckily, all the controls weren't damaged, so I changed the wiring just a little bit so it would work with the new setup. Once everything is put back together, we're going to install the control box. We'll start by cutting this piece of steel. This is what it's going to be mounted to, so we're going to weld it on the side of the stand. After painting, we're going to install the control box, and now we have to tie all the different controls and sensors together. I drew out this diagram here, that way it's much easier for me to do all the final wiring. I tapped an extension cord in, that way all you have to do is plug it into the wall and it will power everything here. I had to troubleshoot a couple of things and I ended up having to redo the wiring a bit, but everything works. Finally, all we have left to do is to leak check all these joints. All the gas joints have been checked and luckily there are no leaks. So we've completely redone the electric, the gas, the metalwork, and all the insulation. And now it's time to test it. Restoring this has been a long journey and I certainly learned a lot and I hope you did too. Now without further ado, here is the final result. If you want to see what kind of art we make with this, then be sure to subscribe, and as always, thanks for your time.